computer. Okay, so I'm recording it now as well. So peak. So peak is an intermediate operation. It'll only run when it hits a terminal operation. Okay, so I create a stream called cow stream. Cow stream contains these 3 cows. Okay, so cow stream.peak. So what does it do? It takes each cow. Okay, it takes each cow, and there's a run method inside the cow class. There's a milk method inside the cow class.
GA, please call reception. GA, please call reception.
Morning,
Thank
Jess.
you.
So what happens is it calls, so print off, this can be a superclass of cow. So this can also be an animal. Okay, so this dude here can also be an animal. So A refers to each cow in this stream. So a.run is going to call the run method for the cow class. A.milk is going to call the milk method of the cow class. Now, none of that will run until it hits the count operation. Okay, so intermediate operations do not run until a terminal operation is called on the stream. Does everyone understand that? Yes? So, next one then, I did a stream of animals. Okay, now stream of animals can have animals. So we have an animal class, it's beneath this guy here. Okay, we have an animal class, and the subclass of animal is cow. So if you have a stream of animals, it can contain both animals and cows. Okay, so then I go animal stream.peak. Now, none of this runs until it hits the count. Okay, count is a terminal operation. What does it do? Counts the amount of animals that will be created in this stream. So we'll have 1, 2, 3, 4. Now, as this is a stream of animals, okay, as this is a stream of animals, you can't call the milk method. The milk method is available only to cows, okay? And this stream contains animals. Now, animals do not have a milk method, okay? Now, these cannot exist in a stream of cows. They can only exist in a stream of animals. That's why here we go, a.milk will not run. Yes? Everyone okay with that? Okay. Now, so we're going to do a few more peaks. So, I am going to go, I'll just take out this guy. So I'm going to create a stream down here. Okay. So we're going to say stream.of this guy up here. Okay. Now I'm not going to assign it to anything. So we're just going to operate on this stream. So stream of orange, apple, carrot, cabbage. And then I'm going to go dot filter. Hold on a minute now, why isn't that fucking? And I'm going to go, takes a string. Hold on a minute now here. Oh, I'm outside the method, sorry. I'm outside the method, I'm outside the method. No, I'm not. So we go s dot starts with C. Sorry there a minute, there's something wrong here now, I should figure it out. Sorry, just bear with me here a minute. Something not working quite right here. No, this should be working fine. So there's something wrong here. Yeah, so that works fine here. Okay, I have it outside the method. That's wrong. Sorry. Right, so stream of orange, apple, carrot, cabbage. Filter, it starts with C, okay, dot peak, and I just want to print it out. Now, if I just did that, nothing happens with that, okay? If you just have that stream, what does that print out? That prints off nothing, okay? It also, nothing is created there either, okay? Stream off. Strings will only be created if there's a terminal operation in the string. There is no terminal operation in the string, okay? That produces stream A, and then this produces stream B and closes stream A. Now, peak produces stream C, which is based on stream B, but it closes stream B. All right, now, if you have that sort of stream, that's going to do absolutely nothing, okay? Nothing happens with that stream. To even prove it, if I just put a little print statement above us, this does nothing. So run from main. Let's see, this is EX7. Okay, does nothing, and also you can see the code there is not still running. Okay, so if you don't have a terminal operation, stream won't run, nothing happens. So there is no terminal operation. So the code will never run. Okay, also after this line here, there's no way to get back to that code because peak produces a new stream. Okay, it produces a new stream that's not assigned to anything. Do you understand that? So peak produces a new stream that is not assigned to anything. So this statement is liable for garbage collection as soon as it is created. Okay, so that does nothing. Okay, it only does something when it hits a terminal operation. Now you can write it over one line, but it's probably easier to write it over several lines. Okay, that's the creation part. That's a intermediate operation. And this is also an intermediate operation. Each intermediate operation closes the previous stream, creates new stream. Okay, same with this one. Closes previous stream, creates new stream. Okay, this one here creates a stream. Now, No terminal operation, so that does nothing. Okay? So if you're asked that in the exam, you're going to be asked, what does that print off? The answer is it's going to do nothing. Okay? Now, to get this to do something, you have to do a terminal operation. So I'm going to do the exact same again, but I'm going to do a so let me just check something here. Now, so I'm going to create a long here, long count, okay? And I'm going to do the exact same here again. But I'm going to go dot count. Now the peak is running, okay? So this intermediate operation closes previous stream. Now this is a terminal operation. Okay, causes the code to run, returns a long, and closes the stream. So an intermediate operation also closes the stream, but it returns a new stream based on the old stream. Okay. Now the main thing a terminal operation does that's different is that it causes the code to run. This is what they call lazy instantiation. Remember those singletons? We did lazy instantiation of the singletons, what seems like a lifetime ago. Okay, this is the same thing again here. All right, so we have, there is 4 distinct stream operations here. This is the first one. This is what creates our stream. We have this guy here. This filters out only the stream, only the strings in the stream that begin with the word C. So we should get carrot and cabbage. Now the peak is just going to have a look at it. Okay, so it should print off carrot and cabbage. Then we get a count that should give us 2. We want to see what does it print off. So we'll go here. So amount strings is plus count. Okay. So this is the peak code here. Okay. So when you print statement above it, this code runs. So we can see that this guy does nothing. Okay, does nothing. This code runs. It will print off carrot and cabbage. Amount of strings is 2. Yeah. So you have a stream, creates these 4 strings. We filter out only those that begin with C. So we get rid of ardent, we get rid of apple. We then have a look to see what it looks like. Peak is an intermediate operation, so it'll just print off carrot and cabbage, and then we count the amount of strings and that, and it'll print off amount of strings is count. Everyone with me so far, yes? Yeah? So what are a peak used for? I'll do a few more peaks. Okay. So I'm going to do this line of code. So now, so this creates a stream called numList. Okay. So this, what is this going to generate? Can anyone tell me? Stream.generate math.random multiplied by 100 limit 50. What's that going to generate? Yes. Okay.
Michael Johns, please call extension 243. microtones, please call extension 243. Thank you.
Now, if I wanted to make those numbers distinct, because at the moment we could have duplicates. Yes? Do you understand that? How would I make them distinct? There is you can put in distinct. Okay, so distinct is an intermediate operation. So you just put it in there. Now, that should end up with 50 unique numbers. Okay, let me just get this right. Now, usually don't put your string. So here we have numList stream generate distinct limit 50. Now, usually when you're writing streams, you do put the terminal operation in as well, but you can put the terminal operation in over 2 lines. Okay, that's 1 line of code. So we're going to, and this generates a stream called numList, and it has the potential to produce a list of 50 unique numbers between 0 and 100. Yes? Yeah? Okay. So I previously created a variable called count. Okay. So I want to make sure that there is 50 numbers generated. So I go count is equal to numList dot peak. And so it takes in a string. I'm going to make this consumer object a bit longer than normal. So I'm going to say number is now I should really make that, yes, it's a string, or it's an integer, sorry, so I should say in. Okay, so what that's going to do, that's going to print off 50 numbers. Yes? Okay, now, but I decide, do you know what? I don't want 50 numbers. So after that, I put in a so I'm going to limit it to 20. Now, we're still getting an error here, so we'll ignore that for a minute, okay? So numList.peak, and then we're going to, so that will print off 50 numbers. Okay, and we want to limit that to the top 20. Okay, and then I go dot peak, and I'll say second batch of numbers is, all right, so go along here. So this first peak is going to print off our 50 numbers. This second peak is going to print off 20 numbers. And that should be system.out. Println. Now, so this guy here is going to print off 50 numbers. This guy here is going to print off 20 numbers. Okay. And then I'm going to go dot count. Okay. So What you're doing here, you're checking to see have 50 numbers been created. And you're checking your 50 numbers. Then we're going to limit it to 20 numbers. And then we're going to print off our 20 numbers. Okay. And then, yeah, so I'm going to leave it like that. And we should be getting 20 numbers at the end of it. So amount of numbers is plus count. Okay. So now here's the thing you need to be careful with peaks. The way it produces, okay. Number is 36, number is 94, number is 38. There isn't 50 numbers being generated there. Okay, so let me think now. I need to work this through. Okay, let me just see now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, I've missed one. There's only 20 numbers being produced. All right. Now, why isn't it printing out 50 numbers? Sorry? Because I limited it to 20. Okay? Because when you limit it to 20, what that does is, so numList.peak, the peak is not going to run until it gets to a terminal operation. Okay? Now, by going numList.peak, so that has the potential to print off 50 numbers. But instead of printing off 50 numbers, but what limits the printing off the 50 numbers is that guy. So only 20 numbers will be printed off. All right. So if you have a couple of limits in a row, so let's say just after this peak here, I printed off limit 10. All right. Now we'll see how many numbers have been printed off here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, what's actually happening there is the following. So peak, now that has the potential to print off 50 numbers, but we limit it to 20. Now, peak, that has the potential to print off 20 numbers, but I limit it to 10. That means only 10 numbers will be printed out. Okay, so it doesn't print off. So this one here is, this is potential to print out 50 numbers.
Ivan Gannon, contact extension 249. Ivan Gannon, extension 249. Thank you.
So then we limit it to 20 numbers. Okay, so this guy has the potential to print off 20 numbers. However, we limit that to 10 numbers, which means that it'll only print off 10. Okay, so it's still working the way it should work. So this is 50 numbers. We limit it to 20. Okay, this is a potential to print off 20 numbers. However, we limit it to 10. And none of it runs until it gets to the count. But by the time it gets to here, it's limited to 10. Okay, so it'll only print that out 10 times. And it'll only print off that 10 times. Okay, so the way it goes is that's a potential to print 50. I'm limited to 20. That's a potential to print off 20 numbers, but then we limit it to 10. And when we get to this point, there's only 10 numbers in it. All right. That's the thing about terminal operation. So when I get to count, the stream is only producing 10 numbers. So if you're going to be using limits, you're only going to get a maximum of whatever the last limit is. Do you understand that? Yes? No? Okay. Right. Now that's fairly important. So the upshot of that really is don't use too many limits. Okay. Only use one. If you want to filter out a list, what should you do? You use the word filter. And you only use limit as the second last operation. Okay? You only use limit as the second last operation. So now, what is a peak really for? So peak, if I go here, I'll just put in here first. This will only produce 10 numbers as the first peak has the potential to produce 50 numbers, but we then limit to 20, and the next peak has the potential to produce 20 numbers, but we then limit to 10. So the code only runs when we get to the terminal operation count, and at this point our stream is limited to producing 10 numbers. Is everyone okay with that? All right. So be careful with using multiple limits. It doesn't work by, it doesn't print off 50, then 20, and then limit 10. That's not what's happening there. Okay. That is limit, that whole guy there is limiting our list to be of 10 numbers. All right. Because that starts off at 50, that limits it to 20, then that limits it to 10. So by the time it gets to the terminal operation, it's got a limit of 10 on it. Okay, so it's this last one here is what produces the amount of numbers. Okay, now, so what is peak really about? So peak is really only supposed to be used when debugging code. Okay. So it shouldn't really be, let me just go in here. So it shouldn't really be, it should not really be changing the code. Okay, So this is an example of bad P code. Let's put it in here. Right, so I'm going to be producing a stream of integers. Okay, so let me just see. So I'm going to use this guy again. So stream.generate math.random. Okay, now if I go, so that'll produce a set amount of numbers. Okay, now if I use a peak, there's nothing stopping me from taking each number and multiplying it by 2. And that's going to produce so hold on a minute now. So peak takes a consumer object. So I'm going to go in here. And I'm going to put this code inside here. And I go, okay, why is that? It takes a consumer. In is equal to in multiplied by 2. Now, so what I'm doing here is I'm generating 100 random numbers, and I'm going to peak. I'm going to have 2 peaks in a row, which you can do. So the first peak is just going to print off those random numbers. So I'm just going to go right. So what I have here is this will generate, and I want to limit it to 10, of course, as well. Sorry, limit it to 5. All right, so produces 5 random numbers. Then I'm just going to print them out. Then I'm going to use a peak to double them. Okay, and then the for each is going to print them off. Now, that's considered bad peak code, because what is the peak doing? The peak is actually changing each of the numbers. All right, so the peak is, so this is considered, put it here. This, that's not put this, yeah, this is considered bad peak code, as peak is only for checking your values, not changing them. Okay, so that's considered bad. So to prove now, so it's going to limit 5 numbers, so it's going to print them off, then it's going to double them, and you're going to see the double here. So if I go here, so let's see, right. Hold on a minute now. That didn't exactly work the way I thought it would work out. Give me a second. Right. So I'll go here. So it takes in, and I'm going to say in is plus in. Okay. Why is that guy giving me an error? Yeah. That for each. Give me a second there again now. Peak dot reach. All right, so let's say that. N is 72. N is equal to N multiplied by 2. Why is that not changing? That should be changing. So let me just see. N is, double N is 2. Double N is 46, double N is 76, double N is 42, double N is 76.
Just double, but it's inside the peak.
Yeah, it's inside the peak. Okay. All right, because they're numbers. All right. Now, I forget there's something to do with numbers that I can't remember. Okay. So when the numbers, your peak doesn't change them. All right. Now, if they are something like an employee, okay. So numbers are a special case, the peaks. All right. So do you know what? I'm going to comment out all of this guy. All right.
Is that not, because peak is the consumer, so is that not right, that it doesn't give anything back, just takes it?
No, but Jason, I'll show you in a minute. I'm going to be having four employees, and I'm going to change something about the employee, and you'll see it's changed outside of it. Do you understand me?
Yeah.
Oh Jesus, yeah, of course. Hold on. Yeah, that's yeah. Okay, I'll come back to that. I know what I've done wrong there. All right. So I'm going to create 4 employees. EMP1. Now, employee, we'll have a look at it here. It takes an age and a string. Okay. So I'm going to employee1 is equal to new employee, and we're going to say to Eddie. We're going to say EMP2 is equal to new employee 3 Adele, and we're going to have an employee EMP3 is equal to new employee, and this is going to be 5 Etna, and the 4th one is going to be employee EMP4 is equal to new employee 6 Edgar. Okay. Now I am going to make a stream with those 4 employees. So I'm going to go stream employee EMP list is equal to stream dot of EMP 1, EMP 2, EMP 3, EMP 4. Now, so I am going to change EMP list yeah. EMP list dot peak. Now it takes in each of the employee objects and it goes e dot set age 20. Fuck yeah. Now what that's doing is that takes in an e. I have that inside here. Dot for each. Now, what this is doing is this is taking a existing stream of employees that contains employees with the ages 2, 3, 4, and 6. And the peak changes all of their ages to 20. Okay, it changes all of their ages to 20. And so if I have a look at them, see, they're now all employees that have an age of 20. Now, if I come along here and if I try to print off each one of their ages, see what happens? So this is EMP1. We have changed the age of the employee with a peak, which is considered bad practice. Is that okay? Now, if I generated employees, so I'll just explain what's happening here. Okay, so this is a stream of employees, of existing employees with all different ages. Okay. Here, the peak changes all the ages of all the existing employees to 20. Okay, so this is changing existing employees using a peak, and that's not what a peak is about. A peak is only for looking at things. If you want to change the ages of the employees, you should use for each instead. Okay, if you want to change all of the ages of the employees, you should be using for each instead. Good morning, Roland. Is that okay, everyone? Yep. Right. So I'm going to show you this thing, why this thing didn't work. So I am going to create a stream of employees. Stream.generate. Now, it takes a supplier. Okay, so it's going to take in this guy. And it's going to take in, it's going to return an employee object. All right, how are we going to generate an employee object? We are going to go return new employee, and it's going to take, the first variable is going to be this guy, int math.random multiplied by 100, and their name is going to be Ed. Now let me just see. So I need to do multiply by 100. I don't need brackets. Stream.generate. So that's going to create a new employee. Now I'm going to have a peek at those employees. I'm going to limit them to 5. Okay. I'm going to peek at those employees. Okay. So that's going to print off the 5 employees. All right. Now I'm next going to do some peek code to change each of the ages. Okay. I'm going to do some peek code that's going to change all of the ages. So it takes in an employee. So it takes in an employee. And inside the peek, so I'll put this on the next line. So what I'm going to do, I'm going to go e dot set age is going to be e dot age multiplied by 2. Okay. And then I'm going to print off the new age. Then I just go e dot get age. Then I'm going to do a for each at the very end. And this is going to be simply in. Now, and it has to be get age. Right. Now, so it looks complicated, and it probably is complicated. So what we're doing here is we're generating an employee. Then we're limiting it to 5. Then we're printing off that employees. Then we're going to change the age of the employees, and it should say new age is e.getAge, and then it's going to print them all off. Yes? Okay. Right. So I'm just going to put in a statement here. So generating employees and printing them out. Now, so okay. Age is 0, name is Ed. So why is it, it's not going int.random here. Okay. So I'll say, yeah, so int num is equal to int math.random multiply by 100. Okay, so that should fix that. No.
We still need brackets, and then the math got random itself before the void.
So you, oh, right. That guy.
Yeah. You have to go into
Yeah, you do. Yeah, you do. Thanks, right. Right. Okay. Now, so let's just see. Now, maybe I should print off here as well. SYSO takes in employee, and it doesn't return anything. But I'm gonna go here for each. This goes here. So, and this guy here. And final age is e.getAge. See, it even takes a little bit of, it's hard enough to do it on the fly. All right. All right. So, here we are generating employees and printing them off. Okay. Employee age is 5, name is age, new age is 10, final age is 10. Okay. What am I trying to do here? What am I trying to explain? Right. So, as I said, this is considered bad peak code. Okay. Because what is the bad peak code done? So we're generating employees and we're using the peak to change the age of the employees, which is not what it's all about. Okay. And we can see that the final age of those employees is also changed. All right. So the first employee starts off with an age of 5. However, this peak code doubles his age. And then his final age is going to be double the original age. Similar with the second one. He's an age of 89. And this P code here doubles the age of the employee. All right. So the final age for the employee is double the original age. You shouldn't be using peaks to do that. Okay. Now you can do these changes in any one of those intermediate operations. Right. You can change the values of the age in any intermediate operation that takes a consumer, say for instance, or takes a supplier. All right. But usually if you're going to change value, you're going to do it in the for each. Is that okay? Great. All right. Now, so that's bad. This is also bad P code. So this is also bad P code, as we are doubling the age, okay, of the employees generated in a peak. Okay. Now, so that is stream intermediate operations finished. Okay. So that is streams intermediate operations finished. So I'll stop that recording.